So we're continuing our study of geometry, and the next section is 9.4. It's all about triangles, and we do have to start with some geometry vocabulary. So the first vocabulary that we're going to learn is called a line segment. It's a part of a line that contains two endpoints and all the points in between. And the way that you could draw a line segment, you've probably seen this before, you name it by the endpoints, and the endpoints will be capital letters because, as we learned before, we label points with capital letters, and you would call that line segment AB, and you would draw a line segment on the top to show that it's actually a segment. You would not put arrows on it, and that would show that the A and the B are the endpoints. Okay, our next geometry vocabulary is a triangle. And you've all seen what a triangle is. It's a figure formed by three line segments that intersect only at their endpoints. So we could draw three line segments that intersect only at their endpoints. And again, we would label a triangle by labeling the vertices. Each one of these is a vertex. Plural of that is vertices. Those are called the vertices. And each one of these is called a side. And the way that we label a triangle, or the way that we name a triangle, is by its, first of all, we use the symbol triangle, and we can call it by its letters, by its vertices, C, D, E. That's not the only thing we could call it. We could have called it C, E, D. There are lots of different ways we could call it, as long as we name all three vertices. So the angles here in this triangle are angle C, angle D, and angle E. And the symbol is used for angle. And the sides are made of segments, and we would call those segment CD, segment CE, and segment DE. Okay, it's a very, very important property about the sum of the measures of the angles of a triangle. You may already know this. If you were to add up the measures of the angles of any triangle, you will get 180 degrees. No matter how small or large the triangle is, that is true. So let's actually draw a triangle. And if each one of these measures inside, we'll call it x degrees, y degrees, and z degrees. If you were to add up x plus y plus z, you will get 180 degrees. No matter how small or how large that triangle is, the angle measures will always sum to 180 degrees. If we have some time when we're in class, we'll do a little activity that will help you be convinced of this if you're not convinced of it. Okay, so let's see if we can find some missing measures of angles. We have a triangle here. Two of the angles are given, 133 degrees, and we're asked to find what x is. So using the property that we just learned, that the sum of the angles has to equal 180, you can actually write yourself an equation. 100 plus 33 plus x has to equal 180. So 133, if you add these two together, plus x equals 180. And then using what we know to solve an equation, you can subtract 133 from both sides, and we get x equals 47 degrees. Okay, why don't you try this next one? I've given you a triangle that has three angle measures. Two of them are given, 60 degrees and 70 degrees. You have to find y. Why don't you go ahead and pause the video, try the problem, and then turn it back on to check your work. So hopefully you figured out that you have to add the three together to get 180. So that's 130 plus y equals 180. And then you can know that y must equal 50 degrees. Okay, this problem requires a little bit more thought. It says the measures of I should have written the measures of the angles of a triangle. The measures of, let's write that in, the measures of the angles of a triangle. of a triangle are in the ratio 2 to 3 to 5. What are the measures of the three angles? So it doesn't mean that the measures themselves are 2 degrees, 3 degrees, and 5 degrees. It just means that they are in that ratio. So there's some multiplier. Like it could be 4 to 6 to 10, or it could be 20 to 30 to 50. It just has to be in that same ratio, 2 to 3 to 5. So there's some multiplier. I don't know what it is, and you don't know what it is probably yet, that if you multiply that same number by 2 and by 3 and by 5, you can actually get the angle measures. So what if we were to do something like this? By the way, it doesn't matter if you draw your triangles to scale as long as you label them correctly. So since I know they have to be in the ratio of 2 to 3 to 5, there's some multiplier, let's call it n. So one angle will be 2n, one angle will be 3n, and one angle will be 5n. So I can just write those in, 2n, 3n, and 5n. If I were to multiply, if I were to add those three together, the 2n plus 3n plus 5n, that should give me 180 degrees. So that'll give me 10n is 180, and that gives me, if you divide both sides by 10, that gives me that n equals 18. That's not the angle measure, that's the multiplier. So if I were to wanted to figure out the first angle would be 2 times 18. The second angle would be 3 times 18. And the third angle, those are ditto marks, would be 5 times 18. So 2 times 18 is 36 degrees. 3 times 18 is 54 degrees. And 5 times 18 is 90 degrees. And the way you can check it is you can add them up, and they should add to 180. Let's see if it does. So that's 9 and 9 is 180. So it does check. Okay, there are basically two different ways you can classify triangles. One is by their angles, and one is by their sides. So let's there are three different classifications. So let's start with classifying by angles. So if I were to draw a triangle, let's say I were to give them these measures, 60 degrees, 70 degrees, and 50 degrees. Okay, that's actually called an acute triangle. We talked about acute angles because all the angles are acute. All the angles are acute, meaning between 0 and 90. Okay. A second type of triangle, let's say I tell you that this is 40 degrees, 120 degrees, and 20 degrees. This is called an obtuse triangle. And remember from our angles, an obtuse angle is one between 90 and 180. So this has one obtuse angle. Think about why it could not have more than one obtuse angle. If the sum of them has to equal, the sum of the three angles has to be 180. So if you had two obtuse angles, the sum of just two angles would already be more than 180. So it can have at most one obtuse angle. Then the last type of triangle that's classified by its angles is a right triangle. And that is one where there's a right angle. So let's say this is 50 and this is 40. This is called a right triangle. And this has one right angle. And again, it can't have two or more right angles because then it would already, if it had two right angles, then the sum of two angles would be 180, and you wouldn't have anything left over for that third angle to sum to 180. Okay, so these are the three types of triangles that are classified by their angles. Acute triangle, obtuse triangle, and right triangle. Okay, so now let's classify angles by their sides. So the first type of triangle would be let's say I draw a triangle that has three congruent sides, or three sides that are all the same measure. That would be called, and I show that they're the same measure by writing these little sort of tick marks or hash marks. This is called an equilateral triangle. Equilateral triangle has all three sides congruent. And congruent is the geometry term for equal measure. Okay? All three sides are congruent, or they have the same measure. It turns out that equilateral triangles are also what is called equiangular. We can talk about that a little bit later. But equiangular, we'll say it's also equiangular. That means that all the angles have the same measure. Three angles have the same measure. See if you can figure out what that measure would have to be. If all three angles have the same measure and they have to sum to 180, it seems straightforward that you would take 180 and divide by 3. Each angle would have to be 60 degrees. Okay, the second type of triangle that's classified by its sides is something called an isosceles triangle, and that's where two of the sides are equal. It's called an isosceles triangle. It has, we say at least two sides equal. At least two sides equal. So by definition, or congruent I should say, because that's the geometry term for equal measure. If you looked at an equilateral triangle, you could call it isosceles, but that would not be the best name for it. If it has three equal sides, you should call it an equilateral triangle. If it has only two, then you can call it isosceles. The third type of triangle, classified by its sides, is called a scalene triangle. Scalene triangle. A scalene triangle has no congruent sides. All the sides are of different measures. I do want to point out something about an isosceles triangle. It turns out that the base angles of an isosceles triangle, the angles that are opposite the congruent sides, meaning this one and this one, are also congruent. That's just a little aside there. The base angles of an isosceles triangle, I'm going to just write that here. Base angles of an isosceles triangle, and we'll learn more about this later, are congruent. There are only two base angles. When we learn a little bit more about isosceles triangles, we'll come back to that idea. Okay, I'm going to ask you to classify some triangles by both their angles and their sides. So they're going to have two different names. So let's try one here. Let's say I draw this picture. Don't judge by how it looks, just judge by how I've labeled it. Okay, so if you see that, there should be a couple of things. First of all, you should be thinking about the angles, and you notice that there's a right angle. So at the very least, you know it's a right triangle. And then if you look at the sides, they are all different lengths, 3, 4, and 5. So I know it's a scalene triangle. So it's a right scalene triangle. Let's see if you can try the next one. Okay, pause the video and see if you can figure out what that one is, and then turn it back on and check your answer. This one is an obtuse because of the 100 degree angle, obtuse, and it's also isosceles because it has two congruent sides. Obtuse, isosceles. Okay, let's try one more. Okay, so go ahead and pause the video and see if you can figure out what this is, and then turn it back on and check your answer. So this one is also a right triangle because it's got the right angle box there. But it's also, these two sides are congruent because they have the double hash marks here. Now, I could have written single hash marks, but I chose to do double. This is a right isosceles triangle. So mostly what the classwork and homework is that relates to this lesson has to do with classifying triangles or drawing triangles of certain classifications, and also finding missing angles when you're given two angles or given some information to be able to find the missing angles.